Hello, everyone. In this lesson, we will be converting a regular expression into an NFA and then converting the NFA into a DFA. So in order to get started, let me pull up a notepad and type the regular expression, and then I will share my screen. Okay, so to start out with, we will be using the expression 1 parentheses 1 and parentheses star parentheses 0 0 parentheses 101 and parentheses star and end that parenthesis and another star. Okay, so in order to convert this into an NFA, I will be demonstrating this using JFlap. So give me a second to open up JFlap and then share my screen. Okay. I believe you should be able to see this now. So before we open it, let's make sure that the empty string set character is set to epsilon in order to be consistent with the symbol we are using in this course. And we will open up a finite automaton. Let me just go ahead and make sure that's sharing. Okay, I believe it is. Okay, so first, let us start with our initial state. Now, if we look at our regular expression, first we notice that there is a 1. So what this means is that in order for us to get to our next state, we must have an input of a 1. Now you may ask what would happen if we don't have a 1, if another value is given, then that would just go to a garbage state, but we will not represent this in this diagram. Okay, oh, my bad. All right, so next in our regular expression, we have a 1 with a star. So what this means, what the clean star means, is that we can produce any number of 1s, including 0 amounts of 1s, to get to the next state. So what we can do is represent this with a loop, meaning that we can produce any number of 1s before going to the next state, which our next state will be represented as Q2. Or it is even possible to go straight to the next state without even producing a 1. Or loop any number of times and then go to Q2 just for no reason. So now we must look at our next term in the expression. So as we see, there's a term in parentheses 0 0 and enclosed in inner parentheses 101 star and star. Now the star on the outside encloses the entire parentheses, and since there is no number afterwards, what this means is that we could theoretically be in a step state right from the get-go. So we will put that Q2 as a final state. Now, if we look in our expression, if we do produce something, we must look inside the parentheses to see what it would take next. So if we do produce something, it must be a 0 0 in order to get to the next state. So let us add another state, Q3. And then in order to get to Q3, we must have a 0, 0. Now, once we're in Q3, which we must see what to do next. So if we look in the inner parentheses of this expression, there is 1, 0, 1 with a star after this. So what this means is that we can produce any number of 1, 0, 1s, which let us represent here. So it's possible for us to loop 1, 0, 1s as many times as we want. Or it is also possible that it produces no 1, 0, 1s. So we can represent that with the epsilon, or empty set character. So now we have our finished product, our NFA. And now what is next is I will show you how to take this NFA and turn it into a DFA. So let me first open up a new, make sure that the empty set character is set to epsilon, another finite automaton. Okay, so let us first start with our initial state, Q0. And we will look at our NFA to see what to do next. So if we look at our NFA, on input Q0 and 1, we can go to Q1, or it is possible to go straight to Q2 if no 1 is produced here. So we will represent this my bad. Let's set those aside because I'll be able to use those later. So that means that from Q0 on an input of a 1, we could be in state Q1 or Q2. So we'll represent that state like that. And then there we go. So if we are in either Q1 or Q2, if we look at our NFA, Q2 is an accept state. So what this means is that this will be an accept state as well. So now let's look at when we are in states Q1 or Q2. On an input of a 1, if we are in Q1, we have the possibility to loop on input of a 1. So we can display that as such. So now let's look on where we'd go if we were in Q2 and had an input of 0. As we see in the NFA, we need a 0, 0 in order to get to the next state. To represent this with a DFA, we must create an intermediary state first. So if there was a 0 inputted, go to this intermediary state. And then in order to get to the next state, we must have another 0. So as we see in our NFA, if we have a 0, 0, we can be in the next state Q3, but due to this epsilon, we could also be in the state Q2 as well. So the way we will represent this is we will label this Q. We'll label this Q2 or 3. So as we see here, this new state could also be in Q2. And since Q2 is an accept state, we must represent this as an accept state as well. But since we are also have the possibility to be in Q2, in case another 0 is read, we must have a transition back to the intermediary state, so that if a 0 is read, it would go to the intermediary state. And then if another 0 is read, we have the chance to be in either Q2 or Q3 again. So now, say we are in Q3. If we look at our NFA, we can produce any number of 101s. So in order to demonstrate this in our DFA, we must create more intermediary states. So as we can see here, say we have an input of 1, we could go to this intermediary state. Say we have an input of a 0, after that, we go to this intermediary state. And then after another 1, that would give us the 101 that we have here. And with input of that, on Q3, we could either be in Q3 again, or due to the epsilon, we could as well be in Q2. So this is how to represent this as a DFA. Let me just make this a little cleaner, a little simpler to read. Oh, there shouldn't be an extra state there. My bad. Let me just fix that. Okay, so there we go. That is how to take this regular expression, convert it to an NFA represented here, and then to convert this NFA into a DFA represented here.